This is USACO 2016 January Contest Silver. Problem 1, Angry Cows. Bessie the cow has designed what she thinks will be the next big hit video game, Angry Cows. The premise, which she believes is completely original, is that the player shoots cows with a slingshot into a one-dimensional scene consisting of a set of hay bales located at various points on a number line. Each cow lands with sufficient force to detonate the hay bales in close proximity to our landing site. The goal is to use a set of cows to detonate all the hay bales. There are n hay bales located at distinct integer positions on a number line. If a cow is launched with power R landing at position X, this will cause a blast of radius R, destroying all hay bales within the range X minus R to X plus R. A total of K cows are available to shoot, each with the same power R. Please determine the minimum integer value of R so that it is possible to use the K cows to detonate every single hay bale in the scene. And the first line of input contains N and K. The remaining N lines all contain integers, each in the range 0 to 1 billion. Please output the minimum power of R with which each cow must be launched in order to detonate all of the hay bales. We can solve this problem using binary search, but before we get to that, we can take a look at a sample input and see how this problem is going to shake out. There are 7 hay bales and 2 cows available to shoot. And there's one at 20, one at 25, one at 18, one at 8, one at 10, one at 3, and one at 1. Let's make a grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll just test with these values first. So there's going to be a hay bale at 1, 3, 10, and 8. And we need to find the minimum radius of each cow's explosion that can detonate all of these hay bales. Of course, there's going to be more in the actual data, but we're just going to test with this. So, for example, 5 would work because let's say a cow was launched over here. It would have a blast radius of 5, so 1, 2, 3, 4. Actually, the cow could be launched over here, and it would reach over 1, 2, 3, 4, 5, and 1, 2, 3, 4. So it would destroy everything here. And we need to find the minimum value of this so that we can get rid of every single one of these hay bales while being restricted with the number of cows we can throw. We can solve this using binary search by I'm assuming that everyone watching knows how to utilize binary search in problems such as these. And after getting each middle value from the binary search, this middle value can be used to test if a certain power works or not. And we can create a method that checks if that middle value works. Let's call it check for now. Int power. And the thing is, it's not just gonna be like the range from the first cow getting detonated to the last cow isn't going to be this. Instead, it's going to be power times 2, because if there was cow here and here, we're gonna set the cow, throw the cow at the middle, which would have the radius to the left and to the right. So the maximum distance that these two cows can have in between would be power times 2. With this in mind, we can check if this power works by going through the cows. We'll keep track of how many cows we use. And set previous, which would be the first out of the list of cows that can be detonated by each cow. And previous, and if distance from previous and current, and we'll be looping through the cows. We'll be iterating through the cows and testing the distance between previous and current. And if this exceeds power times 2, then we will increase cows by 1. And then at the end, we can test if this cow's value exceeds the number of cows we have. Because if it does, it's not going to work. Now we can get to program. First, this is my code, and first we take care of the input and the output and the function initialization. We read the input with the buffered reader and take care of the output with the point writer. We get the integers n and k. N stands for the number of hay bales and k stands for the number of cows we have. And I wrote cows here, but I actually mean hay bales. And I stored all of the indexes of the hay bales in an array and then sort it, since we'll need to use it later. And in the solve, we have a binary search algorithm that checks whether a value from 0, it's 0 because in the best case scenario, we can explode all of the hay bales without any blast. Only the square, or only the index, only the hay bales at the index that is launched at ignites, and that's enough to get all of the hay bales ignited. That is the best case scenario. And the worst case scenario is if the blast has to be across everything, which is going to be maximum at 1 billion. So we'll do 500 million for high. And what this code does is, we inside a forever loop, we set the index to the starting index to cows index plus power. So we're getting the middle of the blast. And then while cow at cow index is less than index plus power, we're going to increase the cow index. And if count keeps track of all of the cows we've used, if count is equal to k, then we're going to return false since we've used all of our cows. And if we go through all of the hay bales, which means we run into an error because cow index is out of bounds, it's going to be true because we ran out of hay bales to explode, which means it worked. Now we can try running this in USACO. angrycows.java, submit solution. It should be all correct.